Okay, classical probability in Venn diagrams. All right. So, what is the probability of having both a cat and a dog? So, in other words, I'm looking for the intersection. So, the probability of cat dog, very famous TV show, probability of cat dog is 0.12. What is the probability of having a cat? Probability of having a cat. Well, that means this is this circle right here. So the probability of having a cat, probability of cat equals 0.18 plus 0.12 equals 0.30. What's the probability of having a dog? Probability of a dog equals 0.12 plus 0.27 equals 0.39. What is the probability of not having a cat? So here's a not, so 1 minus the probability of having a cat. You said having a cat was 0.3, so this is going to be 1 minus 0.3 equals 0.70. What's the probability of not having a dog? So that's 1 minus the probability of having a dog, which in this case is 1 minus 0.39, is 61%. What's the probability of not having both? Okay, that's 1 minus having cat dog. So 1 minus 0.12. So there's an 88% chance that you don't have them both. What is the probability of having neither a cat nor a dog? So now I'm subtracting out the probability I have any animal, I have no pet, or at least I don't have a cat or dog. I may have a lizard or something else, or one of those very friendly fish that you like to pet. Said nobody. Normal. That's you. I'm sorry if I offended you a little bit. So it's 0.43. So I'm going to slide that down because this was not on the diagram. That's 0.43. Okay. Are having a dog or cat independent events? Well, if they're independent, that means the probability of cat intersect dog needs to equal the probability of cat times the probability of dog. Well, what's the probability of the intersection? 0.12. What's the probability of cat? 0.3 times this is 0.39. And when I multiply them, they're close, but they're not equal. They're close, but they're not equal. So therefore, not independent. Therefore, not independent. What is the probability of having a cat or a dog? All right, this is where I need to use the general addition rule. And the general addition rule is, I'll just write it up here where I have a little room. So probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. But here we're not working with A and B, we're working with cat dog. So we have the probability of C union D equals the probability of C plus the probability of D minus the probability of C and D. Probability of C, the probability of a cat is 0.30 plus the probability of a dog is 0.39 minus the intersection. The intersection is 0.12. And so basically, if I went up and down the street and asked people if these values were actually true, 30% have a cat, 39% have a dog. If I went up and down the street, that would mean that 50% of the people have either a cat or a dog or both. Notice when they say make this phrase, they're saying cat or a dog or both. I know it doesn't say the word both, but this is what it means. C union D means cat or dog or both. And you're like, well, why did I subtract them out? And the reason you subtracted them out is because when I look at this diagram, I drew lines like this, that 12% is counted here with cat, but it's also counted there with dog. So I have to subtract it out because it's been counted twice. What is the probability of having only a dog? All right, having only a dog. Well, if I look at the diagram, the part that's only a dog is the part that doesn't include the red or the cat. So the part of having only a dog is going to be 27%. So this is 0.27. What would probability of only a dog need to be for cat and dog to be independent? So what would be the, it shouldn't say only a dog, it said what would be the probability for a dog need to be for cat and dog to be independent events? Well, since we know that cat dog is 12, and we know if they're independent, so if cat dog is 0.12, cat is 0.3, then dog would have to be 0.4. Had this been 0.4, 0.4 times 0.3, 0.12, then they would have been independent. All right, the last thing. They want us to complete the contingency table for the above situation. All right, and so here we have cat and dog. So this is 0.12. This is dog with no cat is 0.27, and a dog was 39%. Cat with no dog, 18%. No dog, no cat, you have no pets. Give me just a second. It's 61%, can't add. 1.0, this is 0.70, and this is 0.30. All right, so given someone has a cat, okay, given is in the denominator, so 0.30. What is the probability they have a dog? So my intersection, because it's always intersection over given, so intersection over given, so this is 0.12 over 0.3. Given that a person has a dog, so now we're given that they have a dog, which is 0.39, what is the probability they have a cat? That intersection is a 0.12. Let's just slide that up so you can see that. All right, and that will close that video.